Okay, so today is all about rationals with adding and subtracting them. So I thought we would start off with a simple fraction addition and subtraction because we know what to do now when we multiply. We go straight across the top, straight across the bottom. When we divide, we keep, change, flip, becomes a multiplication problem. So straight across the top, straight across the bottom, lots and lots of factor in there. So what do we do now if we're adding fractions? Can we add fractions like those two are right there? No, what do we have to do? Get the denominators to be the same. So that's why I told you guys to grab some colored pencils because you need those colored pencils to help figure out what you put on each denominator and what you need. So how do I get denominators the same? Multiply. I'm going to multiply fractions to get them the same. What would I multiply this first fraction by? 4. And if I multiply the bottom by 4, I have to multiply the top by 4. It's kind of like I'm multiplying by 4 over 4, right? The 4's could cancel out. Okay? What would I multiply the second fraction by? 3. And if I do it at the bottom, I have to do it at the top. So now my fractions are 8 over 12 plus 15 over 12. And then I can add those together. And how do I add fractions now? Add the numerators. What about the denominator? It stays the same. So 8 plus 15 is 23. And then at this point, I need to check to see if I can reduce that fraction, right? So can I reduce 12 and 23? No. So that's what we want to do now when we have polynomials in our fractions, when we have our rationals. We got to get common denominators. We add the numerator, keep the same denominator, but then simplify at the end. So our first step, though, if we have polynomials, is to factor our denominators out. So write down these 4 steps. So step 1, factor your denominators. Remember how I told you can make at least a 60 on the next test if you just factor. So that's your key thing. But on addition and subtraction, you just work with the denominators to begin with. Then multiply to get those denominators the same. Then you add up your numerators, leaving your denominators the same. But then that very last step is like what we did the first day of this unit. We have to simplify that fraction if we can. So there might be some more factoring and might be some canceling out. All right, so let's start with our first few problems. Let's just go with one at a time, not to get anybody confused. So go ahead and write down number 1. Do I need to make it larger? All right, first, what do you notice? The denominators are already the same. So the first two steps that you just wrote down are already done, right? If the denominators are the same, you don't need to factor them. You don't need to multiply. They're the same. So step 3 is to add the numerators and keep that denominator the same. So we're going to keep 2d plus 1. And now let's add the top. So what do we have on the top? Yep, and put them together. So d plus d is minus 4. Can you cancel out the 2 d's? No, remember Red Rover, they're locked up together. But we can try to factor and see if anything cancels out. So once you get to this point, can you factor that numerator anymore? You can take out a 2. Yep, and what are we left with? Good. Can I factor the denominator? Nope. So it's just a 2d plus 1. So this would be my final answer right here. It needs to be factored and simplified to get that final answer. All right, there's question 2. Why don't you guys try question 2? All right, does anybody want to explain this one to us? What did you get? Anybody? So the denominators are the same. So we add up the numerator. So 1 plus 1 is 2. Are we done? You can. All that's being multiplied, right? What happens to 2 divided by 2? 1. So this becomes 1 over x. Yep, keep the x in the denominator, so don't move it. So this would be our final answer. Just do this one. All right, question 3. There you go. Write that one down. We're going to do this one together because I want to show you what happens when you see subtraction on a simple one, and then we'll do it a little bit different on the next one. So write it down exactly how it looks and then pause. Now, how many of you would prefer to add than subtract? Yeah, most of us, right? It's easier to add than subtract things. So grab your colored pencil, whatever color it may be, and let's change it. I can change this subtraction to an addition, but if I do that, it's going to change the numerator of that second fraction. Right? If I subtract something, that's the same as adding a negative. But you only change the numerator. Okay, now that that's changed, go back to your regular pencil. And now we can add those together. The denominators are the same, so the denominator would stay as x. And what's negative 2 plus negative 1? Negative 3. Can I simplify that? Nope, so that's my final answer. And let's move on to our last one with the same denominators. Now, just like our last problem, the first thing that you want to do is change that minus to a positive. But if I change that to a positive, I have to change everything in my numerator. So both of these are going to change to a negative. It's kind of like you got to distribute that negative into just the numerator. Okay? Now, go back to your regular pencil. The denominator was the same, so we can write 2y minus 1. And now add up those numerators. Negative 5y plus negative y makes negative 6y minus 3. Now, I can't start canceling things out, but I do need to check to see if anything will factor, right? And that numerator, we can factor out a negative 3. If I factor out a negative 3, what am I left with? 2y and plus 1. Because that was a negative. Now, in my denominator, 2y minus 1 cannot be factored, but can I simplify and cross anything out? No. So that's my final answer right there. So again, that last step, just make sure nothing else simplifies. So that can be a little tricky doing that extra little last step. Okay, so y'all feel comfortable with things having the same denominators, right? Okay, let's work with some things that do not have the same denominators, like question 5. But it's really not as bad as it seems. So write this one down. We'll do it together. But think about those 4 steps that you wrote down at the beginning. Okay, so what is the first thing we need to do? What's factor the denominators? That's right. What kind of problem do we have right here? Short trinomial. Now, I like to do my factoring right underneath. So if you want to put some scrap work maybe over here to the side or, to the left of the problem, wherever, but we're factoring the short trinomial. So what multiplies to be the last and adds to be the middle? 4 and 1. Now, I'm going to write them with my normal pencil right underneath. This is how I like to do it. You can follow me or you can make your own method if you want to. Now, the next denominator, we want to factor it as well. Take out a 3. Good. And I'm left with what? X plus 1. So now that you factored your denominators, now we're on to step 2. What's step 2 say? We got to multiply the fractions to get the common denominator. So I grab my other pencil now and then ask yourself, what does the first one need that the second one has? A 3. So I'm going to multiply the top and bottom by 3. It's got the x plus 1, but it didn't have the 3. Now, do the same thing with the second one. What does the second one need that the first one has? X plus 4. You have to multiply by the whole parenthesis. If you do it on the bottom, you have to do it on the top. Are the denominators the same now? Do they have the same parts? Remember, they don't have to be written in the same order, but they do have to have all the same things. They do. So what is my common denominator? 3. X plus 4 and x plus 1. So the denominators are the same. So now we have to add our numerators or just work with the numerators. So now we're going to multiply. We might have to distribute. We might have to combine like terms. So this first one, 3 times 1 is 3. Then I have a plus. Then I have this part. Now over here, I need to distribute. So what's 5x times x? And then 5x times 4. 20x. Now, do we usually see a numerator or a polynomial written that way? No. What should we do with that top part? Standard form. So let's write it in order. 5x squared plus 20x plus 3, and then it's over 3x plus 4, x plus 1. Now we are not quite done here because now we're on to step 4. Step 4 says to do what? Simplify to get our final answer. And how do we simplify something? Factor and see if anything cancels out. So the bottom part's already factored for us, so let's factor the top part. What kind of problem is that? Long trinomial. So let's multiply our first and last term. What's 3 times 5? 15x squared equals blank times blank, and it's got to add to be 20x. What's the largest numbers that you can multiply to make 15? 15 and 1. What's 15 plus 1? Can I ever get to 20? No. So does this factor? No. So there's our final answer. So sometimes you get to that end part and you're like, whew, thank goodness it doesn't factor. Let's just move on. Okay? Now, one other thing I want to say is if you are using your AI to do this, that's not the answer it's going to give. It's going to multiply out that denominator, but we don't, okay? In Math 3 and on your EOC, it's usually all factored out, and that's how they kind of leave it, because that's an extra step. You already mastered multiplying. We don't need to do it again. All right, write down problem number 6. Now, first thing that I would do when I see a minus is go ahead and change the minus to a. And then what's that changing? The top to a -8. Okay? I like to deal with positives. And the reason that I also do this is because if you have to distribute later on, you don't want to forget to distribute the negative with it. Okay. Now that we've taken care of that, let's factor our denominators. How do you factor this one? Take out the 3, take out the GCF of 3, and what am I left with? Good. Over here, take out an x, and what are we left with? Good. So they share something, right? They both share the x plus 3, but missing the other pieces. So this one needs x. So grab your colored pencils. That way you know it's different. Multiply the top and bottom by x. This one needs a 3, so multiply the top and bottom by 3. And it doesn't matter if you put times 3 before or you put times 3 after. Just make sure it's somewhere on the top and bottom. Just make sure it makes sense. Like I like to put my times 3 after the 8, but at the beginning. Now, grab your regular pencil and let's write the common denominator. So they both have 3x and x plus 3. I like to rewrite my common denominator. That way I have it with me the whole time. Now we deal with the numerators. X times x. And then we have plus -8 times 3. So x squared minus 24. Now that we've added, we make sure we can't simplify to do anything else. So x squared minus 24, it almost looks like a difference of squares, but it's 24 a perfect square. So can it factor? So that's it. Boom, shakalaka-laka. All right, then write down number 7. You'll see a lot of problems won't simplify at the end, but there are a few that might, so you always want to double check that. Now this one has a plus in the middle, so we don't have to do any change in there. So let's go ahead and start. Factoring. Yep, let's start factoring our denominator. What kind of denominator do we have first? Short trinomial. So to the side, you can do what multiplies to be the last and what adds to be the middle. Negative 6 and 2, so x minus 6 and x plus 2. Very good. What about our next denominator? 4 and x plus 2. Good. Now change to your colored pencil now that they're all factored, and let's get them the same. So what does that first one need? A 4. And if you put it on the bottom, got to multiply it on the top. What does this one need? X minus 6, x minus 6. Now they have 3 pieces of info, and that 3 pieces is all the same. So our common denominator is 4, x plus 2, x minus 6. Now deal with your numerator. 4 times 1 is 4. Plus, over here we're going to have to go 3x squared minus, and then we should probably put it in standard form. Very good. And last, factor the numerator. So if I start off multiplying my first and last term, I'm figuring out what multiplies to be 12 and what adds to be negative 18. Does it work? It's not going to work, right? Because the biggest thing we have is 12 and 1, so the biggest number we could get to would be 13. Doesn't work. Final answer. Yay! Hip, hip, hooray! All right, I got 3 more that I want us to do just to make sure we've got this. So these were kind of ones that were a little easier. The last 3 might have a little special things here and there with them. It sure is. These are some specials. Got to throw in the special ones. I don't want you doing your homework Sunday night at 10 p.m. going, what do I do? Because Miss Cook's probably already asleep. Now we got a plus in the middle, so we're good. Let's start factoring our denominator. Xavier already said it's a difference of squares, so this factors to be. Can I factor x plus 4? No. What do you notice about these 2 denominators? They have nothing in common, right? Nothing in common. So would I multiply this one by? X plus 4. Now this is where the second one, I'm going to add in a little trick for you to make it easier. What do I need to multiply the second one by? X plus 3 and? Now if I do that at the top, I'm going to have to distribute multiple times, right? That doesn't sound like fun, does it? But we know what x plus 3 times x minus 3 is. It is... Oh, so that's your trick. I love that. That was hilarious. Ah, so then you don't have to multiply by 2 parentheses. You don't have to distribute once and then distribute again, right? That's what happens when you have multiplying 3 things. So the little trick is if you already know what it multiplies to be, just put it there. Now, your denominator, you want to keep all 3 parentheses that you have. So you're going to keep them in that factored form for your denominator. Now for your numerator, let's distribute and combine like terms. Oh, I used the wrong color. pretty though. 5x squared plus 20x, and then distribute here. And then combine those like terms again, because sometimes that happens. That's also why I wanted to show this one. Sometimes after you multiply, you still got some like terms you could put together. So 5 and 2 make 7x squared plus 20x minus 18. And then we need to check to see if it factors. So let's multiply our 7 and 18. So negative 126. And 20x equals blank plus blank. That's a pretty big number, so don't forget how we can use our calculator to help us out, right? That's right. Type it in. Y equals 126 divided by x, and we're trying to figure out what could add to be 20. And remember, it was a negative 126, and you can put it in as a negative, or you could put it in as a positive. We're just going to subtract those. Is anything on this list could we subtract to get 20? No. Once you get past 9, look how it repeats 9 and 14. And then after that, it's 14 and 9. So it's usually within the first 20 numbers, but I don't see any that could add up to be 20 either. So it doesn't. That would be our final answer. I can't. One of these on your homework will, though, I think. I don't really know. All right, write down the next one. We got 2 more to do. Now, first, we see a minus, so grab that colored pencil, change that minus to a positive, and then you change everything in the numerator. If there were multiple things, you would change multiple parts, okay? And then what do? Factor denominators. Y squared minus 25. Now, our next denominator is just y minus 5. Does that factor? No. But let's, that's right, multiply. On that second fraction, we need to multiply by y plus 5. Do I have to multiply both fractions by something? No. That's why I wanted to show you this one. Sometimes when you're factoring, you get everything that you need by just multiplying one of the fractions. You don't have to multiply both. So keep those denominators, y plus 5, y minus 5. In the numerator, we got 3y. And then we distribute with the negative 8. So negative 8y minus 40. Which again, this is another one that we could go ahead and simplify that numerator a bit more, add those like terms, we get negative 5y minus 40. But that can be factored. We could take out a negative 5, good. So that is y plus 8. And nothing cancels there, so that's got to be our final answer. So don't forget that last step. Once you've combined, try to factor that numerator just to check to see if anything can cancel out. Good thing we don't have to state restrictions, right, guys? All right, last one. This is our last problem. Now, this one looks simple, but I don't want you to mess this one up. Okay? This one could be tricky. And we might have to talk about it with some real numbers in there. Because I guarantee most of y'all will want to say to do what? Add 3 Yep. If we added 3 to that fraction, it would be the same, right? Is that legal, though? Look back at those 4 steps. Is there anything that said add to make a fraction the same? No. So let me show you this fraction. I'm just going to do an example over here to the side. Let's say I'm going to use y'all's favorite numbers. Okay. Now, we're saying that if we do them like the other problems before, we multiplied. So if I multiply the top and bottom by 2, I end up with 12 over 14. And if I reduce 12 over 14, I still get 6 over 7, right? Okay. So we're saying now what we would need to do is we could just add 3 to the top and the bottom, and that would be 9 over 10. Is that the same equivalent fraction? No. So can we add? No, 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 no. We have to do what? Multiply. So treat these like they're in parentheses, and if you need to, put parentheses around them. So what does the first one need? An x. So you multiply the top and bottom by x. What does the second one need? X plus 3. And this is another one where I wanted to show you guys that the denominators were not the same at all. So it's kind of like you crossed to get those denominators the same. But really, what are we multiplying by? 1. What's x divided by x? Well, it cancels out. It's just 1. What's x plus 3 over x plus 3? 1, because it cancels out. So our common denominator is x and x plus 3. And then we simplify those numerators. We get x plus, good, distribute, get your 2x plus 6, which becomes, which has a, it's got a GCF of 3. So x plus 2. Can any of that cancel out, though? No. So that would be the final. All right, you have 45 minutes of class time to work. Now, what I want you to do is I want you to spend the first 30 minutes working tonight's homework, because I want you to make sure it's in your brain so 3 days from now when you finish it, you remember how to do it, okay? At 9:30, if you need to go back to last night's homework to do it, to ask questions, you can. But first 30 minutes, you're working tonight's homework, which is there. Don't forget your take-home quiz is due Monday and your big project is due Monday.